presentation was given at university in Devox, Belgium, last month. I created it with a guy, Antoine Sabot-Durand from Murex, which is an editor, and we use all the use case that Antoine found in his in the tools he created for the software he's developing, and it was interesting. I won't show all the stuff we had in the university, but if you have the chance to have a Parlays access, check our university when it will be online. I think it has very interesting content. So I won't present me again. So we'll have two main topics in our advanced CDI session. First will be around the CDI SPI. Very important things to understand how to use CDI in advanced mode or use the CDI portable extension feature. And the second part will be about the CDI extension. So let's talk about SPI. So I'm not sure if everyone is familiar with the SPI concept. SPI versus API. SPI is API, in fact, is class or interface that you use in your code, while SPI is interface, mostly interface or class that you extend in your code. So CDI provide more way to extend stuff and create new behavior through extending interface or implementing interface in your code. So we have an SPI in CDI. CDI SPI can be split in 4 parts. It's a logical split, it's not a physical or but I think it's better to understand the SPI to have this way of organizing the different parts of the SPI. The first part is related to type metamodel. So it's a way to define type and to manage type. We will dive in it right after that. The second part is related to all the CDI metamodel. So the part linked to the bin, producers, the injection point, injection target. We already saw a few interface from this CDI metamodel part, like the injection point class interface we saw in the example of the producer is a part of this CDI metamodel. The third part is related to all the CDI entry points. So the way you have to, the solution you have to access the CDI bins, access to their the instances of the bin, etc. And the last part is related to all the interface to develop portable extension in CDI. So let's start with the type metamodel. So the first question could be, why do we need to have a type metamodel? Because in CDI we are using a lot of annotation, and annotation are our way to configure our application. The problem is that in Java, annotation and class with annotation are only in read-only mode. When you get them at runtime, you cannot change the content of annotation, modify the annotation, or add a new annotation. So to be able to change the configuration, we need to have a mutable metamodel. That's why we added to CDI this type metamodel to be able to have a way to change the metamodel and change the configuration. So it's a one-to-one mapping from the Java type. So if we look at the class, I won't go. Don't be afraid. I won't go into all the details of all the interface. But if you look at those classes, it's not directly related to CDI. It's related to type. So you have this annotated first interface, the parent of all other interface. And it's a way to define the type and all its annotation on its method, its constructor, its member, the parameter of its method, etc., etc., its field, etc. So you can see this hierarchy of interface. In fact, it's quite simple and is a way to define this meta model. Second part of the SPI is related to the CDI meta model. So we already saw the injection point object. So you see you have information about the type on the injection point. You have the information about the qualifiers, etc., etc. We have SPI regarding observer methods, so you can act on the observers. We have, and that's very interesting, information about metadata of the event. So we can have more information than just listening to a type, but we have a solution to have information about what was really fired at the bin that fired the event. And we have all the metadata related to the bins. So the attributes of the bins, the types, the qualifiers, the scope of the bin, etc. By the way, you see that interceptor and decorator are also bin. They are special bin, but they are also bin. So you can inject stuff in decorator, inject stuff in interceptor. They are special bin, but they are bin. And you have also the concept of producer and injection target. Injection target is an interesting feature. It's a class that allows you to handle all the dependency injection on an instance and all the life cycle of an instance. So all the add post constrict, add pre-destroy annotation, you can manage this in injection target. I will show you an example later in portable extension part. So this SPI is often used in portable extension, but you can use also them in your application, in CDI application. For instance, you can use it in your code, like we did in the first presentation, in the basic part. We can use the injection point to get information on the place where the bin was requested, was injected. So here we have a nice example coming from the documentation. You see, we defined an HTTP param qualifier. This qualifier has a member of type string, and we added the non-binding annotation to tell that this value is not part of the qualifying mechanism. We have here a producer that will be used to produce all the bin of type string with qualifier HTTP param. So you see, we only have to add the empty string because it's not binding, but we have to put it because it's requested by the annotation. And here we can, from the injection point, retrieve what was in the qualifier, what parameter we asked for to be injected. We can inject the HTTP servlet request, which is provided bin by CDI. So we have the request here that can be injected by your code because CDI provided it. So here we can ask the request to get the parameter with the name that is in the value of the qualifier at the other side. So here you see a way of using that. So I can ask here to inject the HTTP param product ID in this product ID string. So it will use this producer the producer will access the qualifier here. It will see that we asked for product ID, and will ask the request to give the parameter product ID. As I show in the first part, I already show something like that in the first part. We can use injection point to gather information about parameter as type. So I show that in the first slides, in basic slides. So you see here you can, regarding the type you asked for your map, choose an implementation or another. You have information about the injection type. You can use it here. More interesting, you can also use metadata regarding the bin. Here you have something that is not a bin because you have an abstract class, but this abstract class will be used, will be extended to create other bin. And what we want in this hierarchy of abstract service, what we want is to have a resolver bin that has the same qualifiers that the current bin. We cannot know the qualifiers of the current bin because it will be extended later, and there will be qualifiers on that. But we can here inject the metadata of the bin, so not the instance but the metadata of the bin, and use this metadata to gather all the qualifiers that are on the bin and choose the resolver that has the same qualifier. Here I remove all the code checking that such a resolver exists and so on, but you can see what we can do about that. So here I injected an instance of resolver with @any to tell, okay, I want all resolvers without regarding the qualifier they have, and I use the programmatic lookup to do my resolution and to fill the resolver field with the resolver that has the same qualifier than the current bin in an abstract way, so it will be used for all the bin that will extend this abstract service. Another example, I think it's the last one. You saw in the first part that event observers are very listen to a lot of type of event. You can have a subset of the qualifier, you can have a subset of type, etc., etc. You can use the event metadata to restrict your observers and be sure that it will only do things if the event that was fired has the type we want to be sure it has and the qualifier we need. So here we are getting the metadata, reading the qualifiers, checking that the qualifiers has the qualified qualifiers, and that the type are corresponding to payload class. And if it's the case, we do something. If it's not the case, we are not doing anything. So the observers will always be called. We cannot avoid that, but we can choose if we do an action or not doing an action regarding the metadata of the event. The third part of the SPI is all the entry points we have in CDI. So the main entry point that you will use in your extension or on perhaps in your code, but it's less frequent, is the bin manager. It's the way to request all the instance of the bin and all the metadata in your application. Bin manager can also be retrieved by GNDI, so you can ask the bin manager through GNDI, or since CDI 1.1, use the CDI provider, that the CDI class that use the CDI provider to provide you bin manager with the getBitManager static method. So you can get the statically you can get the bin manager, and the CDI class will use the GDI resolution or other type of resolution to retrieve the bin manager. So you can access the bin manager from outside CDI code with this class. You also have this mechanism that help you to manage unmanaged class. So if you have a class that is not a bin because it's coming from a third party or so on, you can still use those classes to have injection, to have lifecycle method like postconstruct, predestroy method call on this object. And last but the SPI dedicated to extension. So we will dive into this different event in the coming part. But all this SPI is only event. So you have here events that are fired at the beginning of the application. When your bin manager is initialized, there is a series of events that are triggered by the bin manager, that the CDI container, and you can use those events in your extension to listen to this different phase of the launch process, to do things to change the behavior of your bin manager, etc. We'll see that in the portable extension part. The SPI interface we just saw, not interface, but interface. So there are events, like I said, and each of these events contains metamodel interface. So for instance, if you take the process annotated type event, it's a kind of vehicle for an annotated type, so in fact a type, a class, and you can use this vehicle to change the way this annotated type will be taken into consideration by CDI. For instance, you can use the veto method to say, okay, this annotated type, okay, you find it, but I don't want it to become a bin, so you can use the veto method, for instance. And each of these events in the extension SPI usually contains a metamodel interface that you can read or use to change its content. So let's talk about our CDI portable extension. So I understand that talking about SPI is a bit can be a bit hard, but it's a good way to start to understand what you can do in a portable extension in CDI. So the portable extension in CDI is one of the most powerful features of the specification. It's not very popular, not very well known for a lot of reasons. I think that the first is we need to understand a lot of things before being able to develop extension. Like the SPI we just saw, so you have to be familiar with all this stuff, so it can be a bit long before having all the stuff in place. And for a lot of time, there weren't a lot of information about portable extension. There are more and more information, blog posts on the subject, but it's still we still need to provide some content about portable extension. So there are work to do on that. And I will add a last point on the problem regarding extension. We meet this issue when each time we wanted to make a presentation, to make a talk about extension. It's quite hard to talk about extension because extension are often used when you want to integrate third-party stuff, third-party framework, legacy code, and etc., etc., etc. And if you want to have interesting use case to show to present extension, you often have also to talk about all the business stuff that your third-party framework or legacy code is doing to be able to explain why you are doing the extension like this or like that. And that's also a difficulty to have an easy way, a simple way to describe extension. So I'm going to leave Santa Claus on his for his Tony. What are we using extension for? So as I said, it's very often to integrate third-party libraries, framework, or legacy components. You can also use it to change existing configuration or behavior of existing configuration. So you can have a configuration in CDI and use extension to change the way it's working. And as these extensions are portable, so portable means that they don't are tied to a specific server or implementation. It's a convenient way or natural way to extend CDI and so to extend Java EE as well. And a thing that it's not very often taken into consideration, portable extension is a way to make Java EE evolve between major releases. For instance, next month we will talk about Delta Spike. Delta Spike project provided some stuff that will be standardized in the next release of CDI. So we develop feature extension that are working today in CDI 1.0 and 1.1, and we can test them, they are working, and we can decide, okay, this stuff is interesting, let's standardize this stuff. But in the meantime, you can still use the extension that is provided by Delta Spike. So you have a way to integrate in a natural way new feature without having to wait for 3, 4, 5 years for a new Java EE version. So how do we develop extension? We develop extension by creating a class implementing the extension interface, and in this class we will be observing the SPI events we saw just before. We have a life cycle of the build manager at boot time, and we can listen to this event. By listening to this event, we can check what metadata are being created, and we can modify this metadata, or we can create new metadata. So more concretely, we have to provide the provider of the service, because the extension mechanism is based on the Java SE service locator. So we'll have the meta-inf/services directory and put the JAVAX expertise and enterprise inject SPI extension, which is the complete name of the extension interface. And in this file, we will add the class, the different class of the different extension that we develop. As set on the slide, so just put the qualified name of your extension in the class file. So you have only to implement this interface extension. This is only a marker interface. There is no method to implement in it. And after that, you can observe the different events coming from the SPI to do things in your extension. So is here your build manager lifecycle. So in this schema, all the gray box are internal step that you cannot have hook on them, but it's interesting to have them to understand what happened. The red box are step happening once. The blue box are the steps that are happening more than once, and they are looping on different events. So let's check this life cycle. So the first step where after the application is starting and the deployment of the application is starting, is to have a before bin discovery event. In this before bin discovery, you can start registering new type and things like that. After that, the container will start to scan all the archive you have in your application. So you check all the jar you have in your application and check all the type. And for each type, it will trigger the process annotated type event. So you can decide to listen to all the process annotated type event or only a subset of this event for a given type, or for a given subtype, or for a given annotation present in the type. After having listened or not to this event, you have a new one-step step in your life cycle after type discovery. So here you can, after having all the type in the application, decide to register a new one. So it's a new opportunity to create a new annotated type. After that, the container will check for eligibility of each type to become a bin. We will process all the injection points present in the application. So it's a way to discover what information are on the injection point, modifiers, type, etc., etc. So you can decide here to register a bin regarding, later to register a bin regarding to the injection point, because you know that there is no real bin, but you will create them dynamically in function of what is asked in the application. For each element that will be instantiated in the application, you can process this element. So injection target are the way our instances are created, regarding the way they are instantiated, regarding the way they are injected, or the way that you call all the lifecycle event on an instance, so the at post construct, at pre-destroy event. After that, you will have an occasion to process all the bin attributes, scope, types, etc., etc. You can decide here to stop the creation of a bin, to read all the metadata and say, okay, this bin candidate won't become a bin. You can have a veto method here in the process bin attributes. Here you have the process bin per se, so you can have more information, but you cannot stop the process here, it's too late. When all the bins are processed, you can start dealing with all the producer and all the observers method that are present in the bin. You cannot have producer or observer method outside of a bin, so it's when a bin is okay to be a bin that we can process the producer and process the observer methods. After that, we have a last step before the bin manager becomes in read-only mode. So that means that after this step, you won't be able to add metadata in the bin manager. So you'll be able to read it, to instantiate, to do whatever you want, but not add new bin or modify existing bin. So it's the last occasion to register a new bin or modify an existing bin. And here we have the last step before the runtime. It's the after deployment validation. Usually you use this step to create instance or add information on the console to say, okay, the extension blah 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 was launched successfully, etc. The application is running, and you have, after the application run, the before shutdown, where you can clean resource and do things here, and the application is undeployed. So it's a rather complicated life cycle, but when you manage all the steps and you understand what you want to do, it's quite simple. In fact, you don't have to bother with the step you don't understand, or you don't see what's the point of this step. You can act where you understand what you want to do, and to do what you want. So, simple example. So I will give 2 examples, and after that we will be finished. So the first example is quite simple.
Antoine, can I just
Yeah,
interrupt you a second? So we're now at an hour and 25. So do you say that you're coming into the last section?
yeah. I have. Let me 5 minutes more.
Okay, sure.
Okay.
Yeah, I don't think it's a problem that we're overrunning, but I think we should probably try and keep it to a reasonable length. So,
Uh, okay. So the first example is about ignoring GPA entities. So it's a commonly admitted good practice to avoid having your GPA entities to be managed by CDI. You don't have it to do, you don't want them to be managed by the entity manager and CDI at the same time. It can be a mess. So you can create this extension that will observe all the process annotated type event. You see that we don't ask for a specific type, but we use the @with annotation where we provide the entity annotation. So we observe all process annotated type of type having the entity annotation. And for each of these process annotated type, we will call the veto method that tells the container, okay, this class can be candidate to become a bin, but you make it not a bin. You decide to remove it from the eligibility of bin. So it's a very basic extension, but it helps to understand the basic stuff. More complex example. So this example is to register a bin from an annotation. So let's talk from a concrete use case. I want to integrate MongoDB with CDI. And by this integration, we want to provide a way to write something like this. So to use an annotation we created at Mongo client definition, giving a name to the Mongo client and the URL of connection. And to put this annotation on a given class in the same spirit that we can use data source definition with GPA to define the data source in a Java 6 and 7 application. And what we want to say is that by providing this annotation, have at runtime the possibility to inject the Mongo client and have it created with the parameters we add in the annotation. So how can we do that? First, we create the annotation. Quite simple. So there are 3 members, nothing to say. Nothing special about this annotation. Second, we have to create an extension. So in this extension, the first things that we will do is to observe the process annotated type with the Mongo client definition annotation on it. So it will catch, for instance, here in my sample, it will catch the any class annotated type. And it will give us, on the annotated type, we can catch the Mongo client definition annotation that we can capture it and keep the information in this annotation. Later in our life cycle, it's at the end of the life cycle, the after bin discovery, we can use the Mongo definition we have here, get the URL, and ask to create a new Mongo client URI from the URL, and after that, use the after bin discovery event to add a new bin. So I'm not sure we have time to go into details here, but what I ask to the bin manager is to create a bin from bin attributes. I will create them from the annotated type of Mongo client class, and I will add a few stuff as attribute, mostly the scope of the bin. And I will provide also a producer factory that will produce our bin. So I can go into detail for the bin attributes. So the Mongo client bin attributes is very simple. It's here. You see, it's only provide application scope when you ask for the scope, and all the other methods are calling the delegate object, which is used to simulate the fact that we created a bin from the Mongo client type. And the second element from the SPI we will use is the injection target factory, a bit more complicated, but not very hard to understand. So we have a constructor with the Mongo client URI here. We create the injection target because it's a factory. The injection target provides a way to instantiate a new Mongo client. So we have the instantiation here, so return new Mongo client. So we use the URI that was given in the annotation here. We return the new Mongo client as the instance of the bin. And we will use also implement also the dispose method to close the instance when the bin will be destroyed. That's it. We have a way with this extension to create a bin and inject it from this annotation. So to finish, what you have to remember, extensions are launched during the beginning of the application, the bootstrap, and they are based on CDI event. Once the application is bootstrapped, when you are at runtime, all the stuff that are in the bin manager is in read-only mode. All the metadata is read-only. You can create new instance, you can check the instance, but you cannot register new bin. And to create your extension, you only have to observe the built-in CDI events in the SPI and create your own extension. And it's finished. Is there any question?
Thank you, Antoine. I don't think so. I think we've been asking questions as we've been going through, but I have asked the audience, so let's give them a minute or two. So I'll just check. I was writing some questions down myself as well, so I'll see if I've got any questions for you.
Okay.
No, you answered all my questions. Thank you. Okay, so it doesn't look like we've got any more questions coming from the audience. So thank you very much, Antoine. It was very interesting.
Thank you for the questions. It was a bit longer than
yes. Well, maybe we'll split the video in half because there seems to be a logical split between the two. So,
yeah, I think so.
We'll do something. Okay, so thank you, Antoine, and we'll see you next month when you're talking about Delta Spike.
Yeah. Okay.
Cheers. Thank you. Bye, Antoine.
Bye. Bye.
And thanks for joining, everybody, and hopefully we'll see you next month. Bye-bye.